Ever thought why differentiation of x to the power n equals to n times x to the power n minus 1? Let me tell you. But before that, let me explain you what exactly is a derivative. So first of all, let's plot the function of a straight line on a graph, which is like this. Now we have to find the slope of the function on 2 points, which is p and q. For this, we can take the x value as x1, and for the q we can take x2. For the y value we can take y1, and for q we can take y2. So we know that slope of a function is the rise in the function and upon run. So slope is the ratio of the change in y and change in x. So change in y is we can denote change in y by delta x and change in x by delta. So the change in y is y2 minus y1 and change in x is x2 minus x1. Also, if we focus here, we can connect these lines together and it will form a 90-degree angle and a theta angle here. So we can see that the tan theta from here will be equal to y2 minus y1 and x2 minus x1. So we can say that the tan theta is also the slope of a function. But in the real world, we don't really have straight functions. Instead, we have curves all around. And now we have to find the slope between the point P and point Q on the curve, so that the x-axis value is x0, and for the Q the x value will be at a distance of h, which will be x0 plus h. For x0, the value here will be fx0 plus x0, and for x0 plus h we'll have the value as fx0 plus h. If we put the x0 in the function, we'll get the value as fx0, and if we put the x0 plus h in the function, we'll get fx0 plus h. You can call them y2 and y1 only. These are just the real depictions of them. So now if you apply the slope formula here, the rise upon run, it will be y2 minus y1 upon x2 minus x1. Here y2 is fx0 plus h minus fx0 upon x2 is x0 plus h minus x0, and at the end we'll get fx0 plus h minus fx0 upon h. This will be the slope, but this is called as the secant. The slope will be formed like this and not like this. This is the original slope, which is known as the tangent of a function. This is called as the secant of the function. So we have found the secant of the function, but for the tangent we have to bring the q point so close to q so that it is approximately equals to q, but p cannot be equal to q, because if p equals to q, then the h value will collapse and we'll get an indefinite result. So for that, h has to approach 0, but h cannot be equals to 0. So for the function of fm, we have got, which is fx0 plus h minus fx0 upon h. fx0 plus h should be really close to x0 but cannot be equals to x0. So we have to put a limit here, and where h approaches 0, and the function and the value of the slope will be fx0 plus h minus fx0 by h. So this will be a tangent of the function. So let's take an example, y equals to x square. We have to find the slope of this equation. So for this equation, we'll put values in this, which is, we know the y value is x square. So we have to find the fx0 plus h of this, which will be x plus h whole square, and fx0 is equals to x square. So for this we will put the value limit m equals to limit h approaches 0 for fx0 plus h minus fx0 by h, and the values will be, this value is x plus h to the whole square and x square upon h. For this we'll simplify this function h approaches 0. We'll apply the a square minus b square here, a square minus b square plus x upon h. From here the x will be cut and h cancels h. We'll get this function as the answer, which is limit h approaches 0 and 2x plus h. When we put h as 0 here, we'll get 2x as the answer. Now if you see clearly, the real function, the main function we had was y equals to x square, and now we have got 2x as the answer, which is what we needed to prove. So now you have seen why the differentiation of x to the power n is equals to n times x to the power n minus 1. This is the fundamental idea of slope, how the slope is originally calculated, but by time we have introduced different techniques of differentiation which helped us in calculating the derivatives of functions really easily and fast. We don't fall into this chaos anymore, but we should know how the derivatives actually work, what actually a derivative is. So derivative is nothing else but the slope of a function, of a given function, and the function is the original function, and then differentiating that function will get the slope of the function.